Welcome back. This is the second lesson recording for IM2, November 16th, 2020. So what are we doing today? We're going to be covering a whole lot of different miscellaneous trig ratio topics. So to start off with, can you tell me in private chat, what is the angle measure? Well, the trig ratio we are interested in is this is the opposite side and this is the hypotenuse, so it's going to be sine of theta. So sine of that unknown angle is going to be equal to 41 over 50. And 41 over 50 using the calculator becomes 0.82. So which angle has the sine ratio of about 0.82? So you look at your trig table and you're looking at the sine and you find what is the angle measure that is close to giving the ratio of 0.82, and this is very close, so the angle measure is 55 degrees. Okay, so the inverse trig function notation, you are always going to see it as sine of -1 of x is equal to theta. Okay, so this -1 does not refer to as an exponent as you have seen before. Negative exponent, this is the inverse function. So this is, you do need to be very careful not to get that confused, where x is the ratio number and the theta is the angle measure. So the input is the ratio number and the output is the angle measure, whose sine ratio is x. And we read it as inverse sine of x equals to theta. So trig ratio and their inverses. With the input of ratio and the output of angle measure, that's the inverse sine, okay, and inverse cosine and inverse tangent. Where you get, if you have angle measure and you know at least one of the sides, that means you can use the ratio to figure out the one of the missing side length of the right angle triangle. And so that's why you're using the regular trig ratios, sine, cosine, and theta. See, the input is angle measure and the output is the ratio. While as for inverse sine, the input is the ratio and the output is the angle measure. So using what we know, okay, inverse trig function, we're going to use sine function because reference angle to 40 is opposite of a hypotenuse. So using the sine trig function, sine of 40 degrees is 20 over 31. That's opposite of a hypotenuse. How this would apply in the inverse sine is you are replacing, you're swapping where the angle was with the ratio, and you're putting the inverse notation here. Sine of inverse is, okay, instead of the ratio, you're putting in the, instead of the angle measure, you're putting in the ratio, 0.65, and then out comes out the angle measure. Okay, or sine of 20 over 31 is equal to 40. All right, so I would like you to try to do card number 3 to 9 of the inverse trig function notation. Okay, so this is card number 3 of Desmos. So what are we given? We are given the side length here, and we're given side length here. Actually, that's the hypotenuse, and this is one of the legs. And we are asked to measure the angle of P, find the measure of angle P. So that means we're trying to find this angle. So relative to this angle P, this is the adjacent because this is next to the reference angle, and 18 is opposite the right angle, so this is hypotenuse. So which is the trig function that we need that deals with adjacent and hypotenuse? That's cosine. Cosine of, we don't know what the angle is, so we're going to write P. cosine of P is going to be equal to opposite of adjacent over hypotenuse is the cosine. So that's going to be 7 over 18. Okay. All right. So then we to do our inverse. Okay. To figure out what P is, you are going to put cosine, and where P was, you're going to put this ratio here. And you're going to put the inverse symbol here, 7 over 18. So you are looking for inverse cosine of 7 over 18. And when I look that up in the trig table, 23 degree is the closest. So I know that this angle measure is 23 degrees approximately to the nearest degree. I changed that. Okay, for card number 4, similar problem except we're trying to find this angle measure B here. And we're given this is the opposite side and adjacent side. Okay, that means we're calling tangent of B is going to be equal to opposite, which is 35 over 21. Okay, and 35 divided by 21, 35 divided by 21 is 1.66, repeating. Okay, so then if I try to do find the from the trig table, okay, okay, and I will find it is very close to B is going to be inverse tangent of, instead of B, I am going to put this number in there, 1.667. So I'm looking for what angle gives a tangent ratio of 1.667, and the closest one is 59 degrees. Okay. All right, what about this? What is the measure of angle B? Round your answer to the nearest degree. Okay, so this time angle B, oh, no, we're looking for angle E. There's a typo here. I should change that to angle E. So if this is the angle that we're interested in, then this is the opposite side, and this is the hypotenuse. So we're calling sine of angle E is going to be opposite, which is 4, over hypotenuse, which is 7. And if I use the calculator, 4 divided by 7 is 0.5714. So now to find angle measure E, I need to do a inverse function. So inverse function means I need to switch E with this number here. Okay, so x becomes y, y becomes x. And so it's 0.5714. Okay, and you're looking at the trig table. You should get the closest angle to be E is going to be 35 degrees. Okay. All right. Now find the measure of angle A. Now we're asked to find the measure of angle A. Okay, and this time we are given all three side length. So we have a lot of options. We could use cosine, adjacent over hypotenuse. We could use opposite over adjacent for tangent, or we could use um, sine, opposite of a hypotenuse. Let's just use cosine. Okay, so cosine of A is going to be adjacent. This is my adjacent, okay, over hypotenuse. So adjacent is 12 over 37, okay? And then I know that 8 is going to be inverse cosine of 12 divided by 37. 12 divided by 37 is going to be equal to 0.3243. Okay, so then I take inverse of that, of cosine of 12 divided by 37, and I get A, measure of angle A, to be close to 71 degrees to the nearest degrees. Okay, now some of you might have used cosine, some of you might have used sine, some of you might have used tangent. Regardless, if you use the right side, you will still get 71 degrees. Okay? All right, then on the last problem, you find the measure of angle A. What function did you use? We used cosine. Why did you use it? I just chose that just because it was close, but it would have been just as correct if I used sine as 35 over 37 and then found the ratio from the trig table for sine, and likewise for tangent as well. All right, so this is the optional exercises, so I'm not going to go into that. Okay, now we're going to move on to card number 10 to 18 of Desmos, and this is where we're going to be exploring number sense of trig ratios. How do the ratios behave? Where do the biggest and smallest ratio happen and why? Okay, so this is the trig table you have created a few lessons ago, plus 1 degree and 89 degrees. I've just added those in right at in the beginning and at the end so that you could see how it might behave as it approaches, gets really, really small. The angles become really, really small and the angles become really, really big. Okay, so look at the sine ratio column. So sine ratio column is here. What is the starting value of the column and the ending value of the column? Okay, so remember the angle is increasing from 1 to all the way to 89. Okay, so looking at the numbers 0.0175, 0.175, 0.342, 0.5, 0. Okay, and what do you notice about all the numbers? It is still less than 1, but it is increasing. This is very, very small number, but then this approaches, it gets very, very close to the number 1. So the smallest value for sine is 0.175, or I am going to be close to for, for 0 degrees. If it's a 0 degrees, it'll be very, very close to 0. The largest value is 1, and that is close to 90 degrees. Okay, so if I gave you 0 degrees and 90 degrees, technically 0 degrees, you don't have a triangle. Okay, 0 degree triangle, that means there is no triangle. It's just two lines on top of each other. And likewise for 90 degrees, it will be two lines on top of each other. It's not a triangle. However, for the sake of argument, we are going to do this. Look at the cosine ratio column. What is the starting value? What about this? Oh, it's starting at 0.999 or close to 1 and for 0 degrees. And then it goes all the way to close to 0 for 90 degrees. Okay? And the cosine ratio values, looking at this, they are decreasing as the angles get bigger. Okay, it starts close to 1 and then gets smaller and smaller and smaller until it reaches 0. So it is decreasing while as sine is increasing. Okay, I will continue in the next lesson recording.